What should procurement teams verify before choosing 5-in-1 versus 7-in-1 professional weather stations? Specification Guide for Agriculture and Research Use. The answer is not just speed. Buyers need to check whether the solution fits real production targets, delivers stable data, and reduces downstream risk for quality control, maintenance, and supplier coordination. This walkthrough focuses on the practical evidence a buyer should request before moving forward with a purchase decision. A 6-use case matrix weighs 5 core weather variables against 2 added exposure sensors for agriculture and research. Comparing sensor coverage by real field use, the difference between a 5-in-1 and a 7-in-1 professional weather station is often presented as a simple sensor count comparison. That framing is too shallow for agriculture and research use. A farm manager, extension project, field researcher, or school science coordinator does not need the largest number printed on a product label. The buyer needs the sensor array that answers the decisions at hand, produces repeatable field data, and can be maintained without turning measurement into a permanent troubleshooting project. A 5-in-1 station usually covers temperature, humidity, wind speed, wind direction, and rainfall. A 7-in-1 system commonly adds UV and light-related measurement. Those 2 additions can be valuable when crop exposure, outdoor radiation, solar context, or field study interpretation matters. They can also add complexity if the institution has no workflow for using the extra data. The better comparison is therefore not 5 against 7 in the abstract. It is core weather data against expanded environmental sensing. One sensor count is not the selection criterion. Sensor count is only meaningful after the buyer defines the field decision. If the problem is irrigation timing based on rain history and temperature, a 5-in-1 system may supply the central context. If the problem is crop stress, UV exposure, or solar-related research, a 7-in-1 system may provide stronger evidence. If the problem is a classroom program that must teach core weather observations clearly, the simpler system may be easier to maintain and explain. 2. The data burden of more sensors. More sensors can improve interpretation, but they also create more placement, cleaning, calibration, and explanation requirements. Research users may welcome that burden because it expands the dataset. Agricultural users may accept it when the added variables support operational decisions. A facility or school buyer may prefer fewer, more reliable variables if the extra readings are rarely used. 2.1 Why more data can reduce practical value. A data stream has value only when a team knows how to act on it. A strong buying decision depends on more than a good brochure. Teams should compare measurement range, repeatability, calibration method, sample preparation requirements, maintenance support, and evidence from real plant use. When those checks are completed before purchase, the business can reduce retesting, avoid production delays, and choose equipment with more confidence.